Hello everyone. I know that you have been so much enjoying my lame jokes that I start out these videos with, so I have another twist on the chicken crossing the road for you. This time I'd like you to tell me why it is that the turtle crossed the road. Well, to get to the Shell station, of course. So, our lesson today will be relating to dividing and multiplying integers, and you'll remember that integers are signed numbers. That means they can be positively signed. We're used to saying 4 times 7 is 28, but the set of integers also includes negative numbers, -2, -18. So what happens when we say that instead of multiplying 7 times 4 to get 28, we say, what is -7 times a +4? What is a -7 times a -4? What happens when we mix up the signs of the numbers that we're multiplying together, which are called factors, or the signs of the numbers that we're dividing? Well, let's just go ahead and let me show you a couple of examples here, and you'll see that there's very quickly a pattern. I'm going to go ahead and talk about multiplying integers first, or multiplying signed numbers. And rather than come up with a rigorous algebraic proof of why it is that multiplying signed numbers works this way, I'm just going to show you some examples. We know that if we say 2 times 4, that's equal to 8, correct? Okay. Well, if we take a -2 times a +4, I'm just going to tell you that that's a -8. Let's just say that you owe someone $2. Well, you have a total debt of $2 or -2. But let's say instead of just owing $2 to one person, you owe $2 to John, and $2 to Mary, and $2 to Susan, and $2 to Dad. Or you owe 4 separate people $2 each. Well, how much money? Do you all of a sudden have $8 that you have put into your billfold? No, you owe a total of $8 to people, $2 to each one of those 4 people, so we have a -8. Similarly, if we said, what is 2 times a -4? Well, here, you owe Mom $4, you owe Dad $4. 2 times the $4 that you owe to Mom and Dad is going to give you a -8. You are $8 in the hole. Incidentally, it's not a good idea to borrow money from anyone. God's Word tells us that the borrower is subject to the lender, and it's best to stay out of debt. But that's a topic for another class. Now, I'm just going to tell you that if both of the numbers that you multiply together are negative, then the answer is going to be positive. So let's look at this and see if we can determine a pattern. In our first problem, we had one positive number multiplied together, and our answer was positive. Second problem, we have a -2, which is a negative number. And I apologize for that country music that you hear there in the background. That is not mine, but my son uses that as his alarm clock to wake up. And rather than start over again, I'm going to just let his alarm clock go off. Now we have, in our third example, we have a positive number multiplied by a negative, and once again, that's going to give us a negative result. Let me go ahead and write these out in positive, negative, negative. And then we saw that if we multiplied 2 negative numbers together, we ended up with a positive number again. So what can we learn from this? Well, we see a pattern. Let's see if we can determine what that pattern is. Let's separate out those problems that give us a positive product. Well, if you'll notice here, the signs are the same. We have two positive signs and we have two negative signs. So what we see is when you have same signs, the answer is positive. You get a positive product. And remember, the product is the answer to a multiplication problem. Product is what results when you multiply two factors together. So that's the one pattern that we have. What happens with the other two problems that we have then? Okay? Well, we have one positive and one negative factor. We have another one positive and a negative factor. So the signs are opposite and you get a negative product. So this is the pattern that you can recognize. Opposite signs. If you have oppositely signed factors, you are going to always have a negative product. Does it matter if your first factor is negative or if your second factor is negative? No, it doesn't matter at all. It's just if your signs are opposite of your factors, you get a negative product. If your signs are the same, obviously positive times positive gives us a positive answer. But also, if you have two negative factors that you multiply together, that will also give you a positive result. So that's all that you really need to know about multiplying signed numbers. So, I want to go ahead and now talk about dividing signed numbers. And there's some more vocabulary that you have to remember. You probably thought, oh man, I only have to learn this when I'm in 4th grade and then I'm not ever going to use it again. Well, you use the definitions of the words that you learn in math for the rest of your life when it relates to math, just as the words that we learned as young children we still use in our English vocabulary. So now what happens if we divide signed numbers? Let's just review vocabulary. 14 over 3 gives us not an even number. So let's do 14 divided by 2 is equal to 7. We have another way of writing this. We can say 14 divided by 2 is equal to 7. And we can also write it this way. 14 divided by 2 is equal to 7. 3 different ways that we can indicate that we're starting with a total amount of 14, and we want to divide that initial grouping of 14 objects into 2 separate groups, each that have the same that have the same quantity in them. So when we take our initial group of 14, we split it into 2 equal groups. We have 7 in each of our 2 groups. Now there's some vocabulary that we have here that you have to be reminded of. And I'm going to go ahead and use a different color marker here. This right here is the dividend. Dividend. And this right here is the divisor, and this right here is the quotient. Okay? Dividend. Divisor. Quotient. One last time. Dividend. Divisor. And finally quotient the last time. And what we're going to see is that the same rules that we used, or the same pattern that we had when we were multiplying two factors together, holds true for when we're dividing positive and negative numbers. And that's because division and multiplication are inverse operations. In other words, they sort of undo each other. Dividend, divisor, quotient. The divisor is the number of groups that you're dividing the initial whole group into. Quotient is the number of items that each of the new groups contains. The dividend is the total amount that you had to begin with. And I'm belaboring the point here because you do need to know this vocabulary. So let's see what happens. You'll remember that when you were began doing long division here, and they called it long division because you remember back to probably 4th grade, you might have, I'm just going to do a number here that's pretty quick. I'm going to divide this by 5. How many times does 5 go into 12? 10. How many times does 5 go into 25? 25. How many times does 5 go into 0? 0 times. So when you were doing these division problems, they could end up being long, took up a lot of space in your paper. But what I didn't take the time to show you is how you were actually working this. First, I said, if I start with a group of 12, and I want to divide it into groups containing 5, how many of those groups can I have? Well, 2, because I said 2 times 5 is equal to 10. And that's where we get our multiplication coming in. Let's go back to here. We have 14 divided by 2 is equal to 7. Because 7 times 14 is 14 and we have no remainder. You remember that? What happens if we have negative 14? If we have 14 divided by a negative 2. We want to see what's going to happen with our dividend, with our divisor. What process are we using here? Well, we have to multiply the dividend and divisor back together to get the quotient here, this number that's underneath our sign, underneath our little house there. Well, what is 7 times negative 2? You remember that just from what we just did with multiplication? Well, a positive times a negative gives us a negative answer, so 14 divided by a negative 2 can't possibly be positive, but it has to be negative because negative 7 times negative 2 gives us a positive 14. What happens if we have 14 here, we know that our answer, or that our quotient, is a positive 7. Is our dividend going to be a negative 14 or a positive 14? Well, we've got that positive there. Has to be positive, doesn't it? Thought I was doing something hard to trick you? No, just making sure you're paying attention. But now let's say that we had a negative 14 here. And we're going to divide this by a negative 2. Well, whatever value we have here for our quotient, we're going to check this by saying the quotient times the dividend has to give us the divisor. So what do we remember? That if we want to end up with a negative product, the signs have to be opposite. 7 times a negative 2 is a negative 14. So we have the same situation going on with division as we do with multiplication. If the dividend and divisor are both negative, then the signs of the quotient, the dividend and the divisor, are both negative, then the quotient has to be positive. And I'm reading from your book on page 23, dividing integers. If the divisor and the dividend have like signs, the quotient will be positive. If the divisor and dividend have unlike signs, the quotient will be negative. You just follow the same rules that you do with multiplication. Like signs are positive, unlike signs are negative. The biggest thing that you come into really with dividing signed numbers is what happens if you have 0. What if you wanted to say 12 divided by 0? How many groups of 0, how many empty groups, how many groups that have nothing, can I get out of 12? Well, let's think about our process here. In order to do this long division, whatever our quotient is here, whatever our answer is here, we have to be able to take this number times this number to get 12. So we have to say some number, we don't know what it is, times 12, some number times 0, sorry. Some number times 0 has to be equal to 12. Can you do that? Well, remember what our 0 property of multiplication is. That says anything that you multiply by 0, the result is always going to be 0. So it is impossible to come up with any number that you can't divide by 0, because to check it back, you're multiplying, and you know that when you multiply any number by 0, you get 0. So in other words, if you have 12 divided by 0, you can't do it because there's nothing that you can multiply 0 by that gives you a result of 12. So we say that division by 0 is undefined. Division by 0 is undefined. There's no such number that if you multiply it by 0 that you're going to end up with anything other than 0. So you can't do that. Division by 0 is undefined. That's essential, that even if you don't right now really understand that you know that you can't divide anything by 0. On the other hand, 0 divided by 12, if you're starting with 0 and you want to divide no money among 12 different people in your Sunday school class. We appreciate the heart that you have to share with other people, but when you've got nothing to begin with, you have nothing that you can share, because 0 times 12 is equal to 0. So anytime you take 0 and try and divide that amount into separate groups, that answer is always going to be equal to 0. So this is a very important principle. Definitions. You can never divide a quantity by 0. Okay, you've got that. And here, any time that you try to divide something by 0, you end up with a result of 0. And that's all there is to chew on about multiplying and dividing integers.